Hello, today I want to solve IMO 2022 problem 2. In this problem we are given positive real numbers and functions from positive real numbers to positive real numbers such that for every number x there exists exactly one y such that x times fy plus y times fx this is less or equal to 2. At first notice that the only such function will be fx equals 1 over x. And in this case, we get that x over y plus y over x, this must be less or equal to 2 for only one integer for x. And clearly, y must be equal to x. Otherwise, we get that x over y plus y over x, this would be more than 2 if y is different from x. And the first step is to notice that x times fx must be always less or equal to 1, and why it is correct. Let's assume that we have found some number x such that x times fx is more than 1. In this case, for x there must be some y such that x times fy plus y times fx, this is less or equal to 2. Because for y, the x is also one integer, and this must be x, we can clearly see that y times fy, this must be greater than 1. Otherwise, if this was also less or equal to 1, 2 times y times fy would be less or equal to 2, and we get the contradiction that for y we can find two numbers, one would be x and one would be y itself. So y times fy must be also greater than 1. And now if we write arithmetic mean and geometric mean inequality for this number, we get that x times fy plus y times fx, this is greater or equal to 2 times square root from xy times fx times fy. But we know that x times fx is more than 1, and y times fy is also more than 1. So this number is more than 2. So we get that x times fy plus y times fx is more than 2. And clearly this is contradiction. So there doesn't exist any positive real number x such that x times fx would be greater or greater than 1. So for all numbers, x times fx is less than 1. And we get that fx is less or equal to 1 over x. And now assume that fx is not equal to 1 over x for some number x, and fx must be equal 1 over x plus d. There d is any positive real number. For x, if we manage to find another number y such that y times fx plus x times y, fy, was less or equal to 2, then we get the contradiction, because we know that already x times fx, 2 times x times fx, this is always less or equal to 2. And now look at how can we find y. Because we know that we can easily notice that this function must be decreasing, otherwise we get the contradiction that there will be unique numbers for x and y. So y, when y is more than x, fy must be less than fx. And if we write this here, we get that y times fx plus x times fy, this must be less or equal to y times fx plus x times fx. So this would be x plus y times fx. And if we manage to find such y that x plus y times fx was less or equal to 2, then we get the contradiction. Now we can write instead of fx 1 over x plus d, so x plus y times 1 over x plus d, this must be less or equal to 2. And because we know that d is positive real numbers, and if we take y less or equal to x plus 2 times d, clearly all such y satisfy this condition. now we have used the fact that d was a real number, and we have break the statement of the uniqueness of y and x. So for every number x, f of x must be equal 1 over x, otherwise we get the contradiction if we assign fx is 1 over x plus d. Well, this was all I want to discuss for today. If you like my videos, please like and subscribe.